Hello, we're going to talk about Chapter 2, and the first section is Relations and Functions. Okay, so hopefully it took a second, you wrote down the definitions. What this means is a relation is any set of pairs, any set of x and y's, okay? It can be anything, okay? As long as there's some relationship between x's and y's. A function, all right, is a specific type of relationship. Okay, or I'm sorry, specific type of relation. Think of like squares and quadrilaterals, right? A square is like a function, okay, whereas a relation is any kind of quadrilateral, okay? So it's a function is like a specific type. The first thing is we need to know domain and range, okay? You have to remember this, okay? I can't tell you how important this is. Domain is your x's and the range is your y's. It's in alphabetical order, D, R, X, Y, okay? So the domain here is going to be these squiggly lines, okay? That represents a set, okay? So these braces, that's a squiggly line, okay? So the domain is a set of all the x values. All right, now typically you'd put them in order, but I'm not particular. I really don't care as long as you get all of them, okay? Your range is going to be the set of all your y's. So 2, 4, 6, I'm sorry, -6. And then here we've got to, again, all right? I don't need to rewrite it, okay? I'm not putting a list of all my y's. I'm just listing the possible ones. So your, you don't need to put 2 twice, okay? Don't repeat them. That's a terrible squiggle, but you get the idea. All right, for number 2, the domain is again your x's, so 3, 5, 2, and your range is all your y values. So in this case, it would be 2, 6, and 4. Okay? Now, these are both relations, all right, but are they functions? Okay? Functions have different first coordinates, so different x values. So, for number 1, every point has a different x. So yes, this is a function. Number 2, every x value is not different. We have a repeated x, so this is not a function. Okay, I put yes or no because that answered the question. Every year I give a test and I ask that same question. I get kids that flip it and they're like, oh, I didn't mean to put no, I thought you meant no, is it a relation or something like that? No, 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 this is a function. If you don't want me to second guess it, or you're messing up your yeses and nos, then put number 1 is a function. Yes, function. No, or I guess you could just say not a function. That'd probably be easier than no. Not a function. Okay, either one. All right, yes, no, or put function, not a function. Okay. All right. Here we have a mapping diagram, okay, where the left oval, okay, or whatever you want to call it, is your domain, and I guess I'll write it out because I can, and the right one is your range, okay, but instead of putting them as pairs, you know, x comma y, we're just going to draw lines, okay. So the points in number 3, you would have the point 1 comma 5. You'd have the point 2 comma 6. You'd have the point 3 comma 7. Again, we're just following these arrows to their y value. Okay? And then again, we have a 4 comma 7. So we look at our points. We can see that the x's do not repeat. So yes, it's a function. All right, number 4. We map these out. we go from 2 to 5. Here we go from 2 to negative 2. We're following each arrow. And then the last one, so there are only 4 points in each of these, okay, because there are 4 arrows. If I had another arrow, that would make a 5th point, okay? So understand each arrow is a point. So here we look at our x values. We can see that the x's do repeat, so no, it's not a function. Okay, so again, we just care about the x's. I do not care about the y's. Okay, only the x's. All right, number 5 are the following functions. So let's see. Well, I could sit there and write out each point, okay? Like I've got a point here and a point here and a point here, right? And I could list them all out and see if the x's repeat. But there's an easier way. Hopefully you remember it. Maybe if I say vertical line test, hopefully the bells are going off. Ooh, write that a little better. Man. Okay, sorry, had a technical difficulty. So vertical line test. All right, so the vertical line test is we take our, here, let me write it out this way. So I'm going to take a vertical line and I'm going to take that, and as I go along my graph, ooh, I probably should have picked a darker color. Let's do green. As I go along, I want to see if my function touches that line in 2 spots. So as you can see, as I go along, that function is only touching it one time, or one spot at a time. Like I'm touching it right there and nowhere else. Okay? So then let's take it to this one. Over here, we've got an issue. Okay? This does not pass the vertical line test because we've got a point right here and a point right here where it overlaps. So my x's are repeating. So this one is a function, and the one on the right is no, it's not a function. Okay, so let's determine the domain and range. All right, this gets a little tricky. I'm going to put this on a new page. Okay, domain and range. All right, bear with me. Let's do this one at a time. So for number 5, let's just focus. I said that kind of weird. Sorry. Let's just focus on the domain. Okay, so what is the domain? The domain represents all my x values. Okay, well, do I have an x value at 0? I have an x value at 1, at 2, at 3, and if I keep going, well, I can keep going in the x direction. So I'm going to keep going up and get all these positive numbers. So this direction is going towards positive infinity. All right, so I'm going to keep having x values. But if I go to the left side, all right, notice I go at -1, I have a point, -2, I have a point, -3, -4. Well, I can keep going on and on and on off my graph forever, and I'm going towards negative infinity. So my domain goes from negative infinity to infinity. Okay, typically you've written this as inequalities before, okay, or you said that it's all real numbers. I want you guys comfortable with a new set notation. Okay, so what we do is we list the tail ends. It goes from negative infinity to infinity. So this is going from negative infinity to infinity. And then it doesn't, you can't actually touch infinity. Okay, it doesn't, you can't ever, like, I can't be counting and then all of a sudden go, whoop, I made it to infinity, I guess I can stop now. You know, that never happens. You can keep going. So since we can't actually touch infinity, we're going to put parentheses. Now I know that looks like a point. It's not. It's the domain, Okay, so understand that I'm writing this as the domain. That's not a point. It's going all the values from negative infinity to infinity. Okay, I know, it's weird. So let me show you the range. So the range for number 5, so we're looking at the y values. Okay, I start at my y value of 0. Well, then I have a y value at 1. I have a y value at 2, a y value at 3. I mean, technically I have 2 parts, right? Okay, 2 values for y, but the point is that I can keep going up. These arrows are going to keep going up. So I'm going towards infinity, right? But if I go down from 0, well, at -1 I have a point, but at -2, there's nothing. -3, there's nothing. There's nothing past -1. So my y value starts at -1, but then it keeps going towards infinity. So it's going to go from -1 towards infinity. Now remember, you can't touch infinity, so you put parentheses. However, we can touch -1. There is an actual point at -1. So I'm going to use a bracket. Bracket means like stop. I hit it. That's where I'm at. Parentheses means I'm not touching it. Okay? All right? So, so number 6. Sorry, I'm trying to keep track of what I'm doing. All right, number 6. Let's start with the domain. So again, we focus on the x values. Okay, so your x values are this way. So I have nothing out here, -4, -3, -2. I have nothing until 0, and then I keep going until 2. I don't have any x values past there, to the left or to the right. I'm sorry, my green line is kind of in the way, so let me get rid of that. Okay, so the domain goes from 0 to 2, and it actually hit at 2, and I'm sorry, it hit at 0 and at 2. So I'm going to put brackets around both of those. See, much easier than inequalities, greater than, less than, all that stuff. Here we can just sandwich it. All right, now let's do our range. Y value. We look at our y values. There's nothing up high until we get to 2. And then we keep going down, and then it stops at -2, right? We're looking this direction for our y's, up and down. Well, it goes from all the values from -2 to 2. So we put brackets. That's it. That's our domain and range. We can write it as a simple inequality as opposed to just listing them out. I'm sorry, set notation. This is called set notation. And it's much better than inequalities. Okay, let's do some more. Well, more problems. So this part is evaluate each function for the given value of x. So similar to what we did in chapter 1 where I had you plug stuff in, all right, this is getting used to you writing it as f of x, okay? I like to think of f of x as just a fancy way of saying y. So instead of saying x comma y, we're going to say a fancier way and say x comma f of x. Okay, sorry, that was a rough looking x there. Okay, so then for number 9, I know what x is. Great, I've got part of my point, right? I've got it's 3 comma something. Well, we need to figure out what f of 3 is. So to figure out what our y coordinate is, we need to plug in 3. So we do -3 times 3 plus 2. So we get f of 3 equals -9 plus 2. Sorry, I'm trying to write all my steps. Okay, -7. So our point is 3 comma -7. All right, number 10, let's plug it in. We want to find it for x is -2. Again, we've got part of our point. We just need to get that y value, right? We're halfway there. So let's plug in f of negative 2. So 1/2 of negative 2 minus 1. Well, that's just negative 1 minus 1. Ooh, rough looking one. Didn't do much better. Negative 2. So here the answer is negative 2, negative 2. All right, number 11. Again, we've got the 12, so that's our x value. Get our y value by plugging it in. 5 times 12 minus 22. So we get 60 minus 22. So 38. All right, number 12. Find f of 3. So 5/3 of 3 minus 3 over 5. Okay, so this one becomes 15 over 3, right? Because you can multiply the tops and the bottoms, so 15 over 3, which is just 5. So now we want 5 minus 3/5. Okay, if you don't remember, we want the same denominator, so we need to change this one to times 5. So then we get 25 over 5 minus 3/5. So then this one ends up being, sorry, I ran out of room, 22 over 5. So our point is 3 comma 22 fifths. So I'll highlight my answers so you can easily find them. And this one, and this one, and this one. Okay, there's my answers. All right. 17. Were we even on 17? Nope, I'm just skipping around. Okay, whatever. So the relation between the length of the femur, F, ooh, that was rough. So that's supposed to be a cursive F. Okay, anyway, so the bone from the knee to the hip joint, okay, so that's what the femur is. The height of an adult woman, H, is modeled by this function. Okay, so again, with this, it's like it just didn't finish my cursive F. All right, whatever. All right, we want to find the unknown measures. So 13 comma t. Well, remember how they wrote this. H of f is just your fancy y. So if that's my y value, if h of f is my y, then my x must be what I'm plugging in, which is f. Okay? So look what we have here. This is what we plug in. Okay, and this is what it equals. So here we're going to have t equals 2.3 times 13 plus 24. So let's see, 2.3 times 13 is 29.9. Then we're going to add 24 and we get 53.9. So t is 53.9. Now for B, this is where it gets interesting. All right, because remember, the plug-in part is this part. So I'm plugging in m. So h of m is just 2.3 m plus 24. And this is what it equals. So 56.2 is the fancy way of saying, or I'm sorry, the better way of saying h of m. H of m is the fancy way of saying that. Okay? All right, so we do 56.2 minus 24. We get 32.2. and then we can divide by 2.3. And here we get 14. Okay. All right, that's it for 2.1.